Hey everyone, so like I said, I'm going to do something different this time. I have a bunch of problem set questions that if you go onto Canvas and you look at the original assignment posted, you can actually download these questions and look at them now. Otherwise, you could just wait as we go through it. As I mentioned in class, what we're going to do is I'm going to post these questions, answer them, and if you want and you get them right, then you can just move on to the next question. Otherwise, if you're interested to see my explanation, then follow along and you can see exactly what I have to do. All right. All right. So here's the very first question. Now, based off of this, the information they give us is well, they want us to figure out the distance that it travels in 4 seconds. Now, one thing that you would want to do is maybe not for this specific question, but just in general, when you're trying to do a problem, you want to be able to write down all the given information. So they initially tell us that the initial speed of the car is 16 meters per second. They tell us that it's brought to rest, which tells me that the final velocity is going to be 0 meters per second. So it's not traveling at 16 the entire time. It's slowing down and coming to a stop. Uh, they tell us that the time is going to be 4 seconds, and we're looking for the distance or displacement. Doesn't really matter. So that's my unknown question mark. The only equation that we have that has d in it or distance displacement would be the average speed equation. Now, the key thing here is the fact that this is average speed, not just speed. Because we have two different speeds, we have to first figure out what the average of these two numbers are. So we kind of almost have to take a quick side equation first and do 16 plus 0, initial plus final, divided by 2, just taking the average of two things, and we end up getting 8. So my average speed is going to be 8 meters per second. The distance is the unknown, and the time is going to be 4 seconds. Plug this all in, and we end up getting that the distance traveled is going to be 32 meters. All right, so this is the next question. Pause the video work itself. I'm going in a second. All right, so what we're going to do is the same thing. They give us the variables. They give us our distance to be 100 meters. We're told the speed is zero point 0.5 meters per second, well, average speed. And they're looking for a time. So we're using the same equation, v bar equals d over t. Plug our numbers in and solve for time. So time is going to be equal to 200 seconds. Choice A. Now, really quick, I just want to point out that at this moment, because I'm using a mouse, it's hard for me to write a lot of stuff. But you should notice that I am including units. You need to make sure that these 3 lines are always included when you show work. You have an equation like this. You should have units either in the substitution like this or on the side like I did over here. And then you need to make sure that your final answer has units. You need to do this for any free response calculation question in order to make sure you get full credit. Uh, Whenever you're doing a free response question, you need to make sure you show all your steps. You don't have to do it for a multiple choice, but for free response, it's good to get into the habit now so you don't forget about it later. All right, here's the next question. Pause the video, work stuff. I'll go in a second. All right. Now, the really interesting thing for this one is that you actually don't need to do any math. You can solve it through process of elimination. For example, there's some really good tips and tricks to notice about the components when it comes to your result. In particular, the fact that this number should be bigger than these two separately, right? So whatever this FH is and whatever FV is, which is going to be over here, 24, it's got these two are going to have to be less than 24. However, the other thing to keep in mind is that the sum of these two will always be bigger than this. This is the one of the reasons why distance is always bigger than displacement, because if I add these two up, this is a much shorter position distance. So if we actually look down here, that would actually get rid of choices B and D, because the sum of those two numbers would not be bigger than 24, leaving us with only choices A and C. And then from there, we can actually also use the 35 degrees to very quickly tell whether or not this object should be pointed more horizontally or more vertically. But if you wanted to actually do the math, what we would do is pick only one side. It doesn't really matter which one. Let's go with the horizontal. This is adjacent to the angle, so we're going to use cosine of 35 degrees. equals FH over 24 newtons. I didn't write the equation because again, I'm using a mouse right now. But when you plug this in, making sure that you are in degree mode, you will end up getting about 20 newtons. So the horizontal component is 20 newtons, which again, if we used our logic and our reasoning skills, would make sense since this angle is less than 45. Then we have an object or a vector that has a very shallow angle, so it should be pointed more horizontally than it is vertically. All right. All right, here's the next question. Pause video, work itself. I'll go over in a second. All right, so once again, we're being if we're trying to get all the information out, we're being told the average speed here. So this is the average speed. This is the distance, and we're looking for the time. One thing to note is because these are not in standard units, I just want to double check what the units they're in. Uh, because if we have some of these units in meters per second and other units in kilometers, uh, we won't be able to use the equation as is. We have to make sure everything is in consistent units. Since this is in kilometers, this says hours, this says hours. That tells me that I can actually just, uh, keep going business as usual. So I use my equation, v bar equals d over t. I'm going to plug the numbers in, 600 kilometers per hour equals 120 kilometers equals t. Cross multiply, or what I like to do is a cross switch. So I just switch the location of those 2 points. So 120 divided by 600, plugging that all in, and we end up getting 0.2 hours. All right. All right. Here's the next question. Pause the video, work itself. I'm going in a second. All right. So here, this one didn't really have a calculation part. So they want us to figure out what these two cars had the same value of. Well, first off, I could actually get rid of a few choices. Like for example, the change in momentum. Since we haven't actually talked about momentum, it wouldn't make sense for us for that to be an answer. Now, one other thing to notice is that one car is moving east and the other car is moving west. That means they're going in opposite directions. That means their vectors by definition, must be different. So the average velocity and total displacement would both be different because one would have a east displacement and velocity, and the other one would have a west displacement and velocity. So the answer is they have the same average speed. And you could double check by doing 40 divided by 5 and 64 divided by 8 to get that they'd both be going at 8 meters per second speed wise, but in different directions. All right. All right. Here's the next question. Pause the video, works up. I'm going to go in a second. All right, so when you go to do this problem, uh, this is one of those problems where you have to be very careful about. Now, it's extremely important that you pay attention to what's going on. So the big mistake that people will end up making is they'll find the three individual speeds, what the speed during the first hour, during the next half an hour, and the next half an hour, and then they'll just average those three speeds in order to find the average. But you can't do that. You can't do it mostly for the reason that each of these is going for different amounts of time. In particular, this first one is acting for twice as long as the other two. So we don't want to do that. Instead, we want to go with the simplest case and just do distance divided by time, right? My go-to is that if you can do distance divided by time, you should do distance divided by time. So that's what we're going to do here. The total distance is going to be 80 plus 50 plus 40, which is 170. And then we're going to divide it by 2 hours in order to get the speed of, there we go, 85 kilometers per hour. All right. All right, here's the next question. Pause the video, works up. We'll move in a second. All right. So this one can get a little tricky since we haven't talked about the units for two of these at least, so it might be a little bit hard to tell. They do say which one pairs the vector with its unit. That means I can actually get rid of speed. Speed is the only scalar on this list. Weight, remember I had mentioned that is actually, well, I actually don't think I explicitly mentioned this in class, but weight is a vector. Weight is pulling you down, so this one does have a direction. So we have three different variables. One of these has their correct unit based off of what we've been talking about. velocity is the one with its correct. All right, here's the last question. Pause the video, work stuff. I'm going to go in a second. All right, now we actually did this question before, but it was slightly different. Here, what we're going to do is they're looking for the average speed of the player. So the way we're going to do this is by doing total distance divided by time. We have to figure out what the total distance is as the person moves. So he goes from one side to the other side. That is a total of 60 meters. And he does this 60 meters 3 times. So that means he travels a total distance of 180 meters. And he does this in 60 seconds. So that tells us that our final average speed is going to be about 3 meters per second. Now, we did have to be careful because had they changed this term to average velocity, then it's very likely, then our answer would have changed to be about 0 because of the fact that if he starts and ends in the same location, then the displacement 0, which means the average velocity is 0. So this is one of those types of questions where you would want to be a little bit careful about whether or not they said speed or velocity. All right, and that was about it. So these were all regions questions, and I wanted to make sure I went over these, not as an indicator of the type of questions that you would see on the exam, because again, you're going to be seeing AP questions, not regions questions. However, these questions are really good as a way of strengthening the foundation and understanding and comfortability with these equations. In order to answer a lot of AP questions, you have to have a really strong understanding of the equations at hand in order to answer some of the more nuanced and more conceptual questions. Now, you will be seeing those types of questions in a bit. I just want to point that out. But every now and then, we do throw in these types of questions just as a way of trying to strengthen that connection with the equation so that you don't have to struggle about remembering what equations are what. Plus, there are some times where these types of questions actually do appear in a form